24 million humanoid robots. That's the magic number. For the world's second largest economy, the machine revolution isn't a science fiction nightmare, it's the biological lifeline. The 71st edition of the prestigious study published by the banking giant Berkeley revealed a very impressive plan. To survive an unprecedented population collapse, China will need to deploy an army of 24 million humanoid robots by the year 2035. And while that date hasn't arrived yet, the machines are already starting to work alongside human police officers on the streets, learning physical tasks on their own, and even getting ready to operate off Earth. Yeah, this is already happening right now, my friend. At the same time, giant rockets are exploding as they try to turn space into permanent infrastructure. And we can't forget to mention the flying motorcycles that are coming straight out of science fiction. And artificial intelligence, my friend, is already starting to create videos so realistic that telling what's real from a simulation is becoming a huge challenge, you know? Let's explore the creation of the largest synthetic workforce in history and other technologies now. Hello, impressed ladies and gentlemen. I'm Realidad Impressionante, and you're watching Realidad Impressionante. For most of the world, the rise of humanoid robots still feels like a debate about a future that has yet to happen. But for China, it is already starting to be treated as a matter of economic survival. And maybe that's what makes the new report from Berkeley so impressive. According to the study, China may need to deploy around 24 million humanoid robots by 2030. To be able to compensate for the gradual collapse of its workforce. We're not just talking about traditional industrial automation, the kind with the giant robot arms working in factories. We're now talking about a population replacement on a national scale. For decades, China's economy grew, sustained by an almost perfect combination of a gigantic population, abundant labor, and massive industrial production. But now the country faces a severe demographic shift. The population is aging rapidly. The number of young people is decreasing, and consequently, the workforce is starting to shrink at a rather worrying pace. According to Berkeley himself, China could lose around 37 million workers over the next decade. And this is where physical AI comes into play because the new humanoid robots are no longer those rigid arms that are fixed to isolated assembly lines. The new generation was designed precisely to operate in environments originally built for us, human beings. They walk, carry boxes, use tools that were made for us, climb stairs, handle delicate objects, and continuously learn through neural networks. It is the third phase of automation, physically adaptable machines directly integrated into everyday economic life. And the financial math behind this is starting to become frighteningly viable. According to the report, the average manufacturing cost of humanoid robots has dropped drastically in recent years. Analysts believe that by the end of the decade, many of these robots could cost less than several current cars. And this completely changes the economic calculation for these companies, because a synthetic worker doesn't sleep, doesn't age, doesn't go on strike, and can operate continuously connected to central collective learning systems. At the same time, each robot deployed generates new data, improves the algorithms, and further reduces the future costs of automation. Yeah, it's an exponential cycle. And the most interesting thing is to realize how this already goes beyond China itself. Because building tens of millions of humanoid robots requires a gigantic amount of batteries, motors, sensors, semiconductors, and strategic metals come into play here. The effect of this economic reconfiguration will echo far beyond China's borders. According to estimates from another bank, Morgan Stanley, the massive use of physical AI will expand China's share in global manufacturing to 16.5% by 2030. However, to build 24 million robots, the consumption of natural resources will be devastating. Reports from Bloomberg and Berkeley indicate that commodity exporting countries will be the big indirect winners of this race. Nations rich in essential minerals like Chile, Peru, Indonesia, and our own Brazil will experience historic growth in demand for key metals for hardware infrastructure. In practice, the advancement of physical AI can reorganize not only jobs, but entire global chains of energy, mining, logistics, and technological production. And there is something deeply symbolic about all of this. For centuries, economies grew by expanding human populations. Now we are beginning to enter an era where economic growth may increasingly depend on the expansion of synthetic workers rather than humans. This Silicon Army described by Berkeley represents the most extreme technological replacement scenario ever projected for a global bank. And even if only half of that goal is reached, the planet's economic machinery will have changed forever. So, do you believe that the global economy will be able to sustain itself through synthetic workers? Or is there something else happening behind the scenes? While you open the comment section below to help me out and leave your comment, in the next few minutes I'll show you some real-world examples of humanoid robots and other technologies being deployed. Let's check it out now. In Shanghai, a new pilot program put a humanoid robot called Lin Lingxi X2 to work side by side with human urban enforcement agents. And the images you're seeing now are real, okay? However, they're not exactly of the robot I'm talking about, they're of other robots that are also already being deployed in China. Unfortunately, I was only able to get this photo of Lin Lingxi X2 working alongside police officers, and you can see that he's talking to the people around him. The pilot project is taking place in the innovation city of Yadezhangjiang in the Pudong district, where drones, police officers, and humanoid robots now operate together in a coordinated urban management system. The operation almost feels like a preview of administrative science fiction. First, drones monitor the streets in real time, looking for irregularities involving street vendors and street vending. When they detect something, they immediately send the information to human agents and also to the nearest humanoid robots. That's when Lingxi X2 comes into play. According to the Chinese company Ajibat, the manufacturer of this robot, it was trained to explain urban rules, answer questions, interpret public policies, and guide merchants about local legislation. In practice, it works as a kind of physical, bureaucratic intermediary powered by artificial intelligence. And maybe this reveals an important change in the role of humanoid robots, because until now, most of the industry focused on physical strength, balance, and industrial automation. But systems like Lingxi are starting to explore another frontier: functional social interaction in highly regulated public spaces. The local government itself states that humans remain responsible for legal decisions and enforcement authority. The robot, on the other hand, only serves as operational and communication support. For now, my friends, because this is just the beginning. Chinese experts state that this project represents an important step in transforming humanoid robots from simple machines into systems capable of effectively working within human society. In other words, the race now is no longer just about creating impressive robots. It's about making these machines economically useful in real human environments. Yes, little by little, cities are starting to test something new: a daily coexistence between practical AI embedded in robots and public life. This progress in humanoid robotics isn't limited to China. Let's see now what the United States is doing with the famous Boston Dynamics. The South Korean company revealed new details about how Atlas learned to lift and carry industrial loads, which are quite heavy, using artificial intelligence, reinforcement learning, and millions of digital simulations. And maybe the most impressive thing isn't just the weight it's lifting, it's the way the robot learns to handle it. In the new tests, Atlas is shown carrying objects like industrial refrigerators weighing over 45 kilograms while continuously adjusting its balance in real time. The robot twists its torso, squats down, calculates the distribution of force, and reacts to internal weight changes while it's walking. All of this without relying mainly on camera vision. According to the company, Atlas uses something called proprioception, a kind of internal body awareness. It's the same principle that we humans naturally use to know where our arms, legs, and center of gravity are, all without having to look directly at them. In practice, the robot senses its own body while it's moving. And to teach this, the engineers didn't manually program each movement, or line by line. Instead, they used reinforcement learning. Atlas spent millions of hours training in virtual simulations run on GPUs, repeating countless movements under different conditions. The researchers changed the weight of the objects, the floor friction, the force needed in the hands, and even small external disturbances to force the system to continuously adapt. Whenever the robot was able to correctly complete a task while maintaining balance and control, it received an algorithmic reward. Gradually, the AI began to discover the most efficient movement patterns on its own. And this represents a huge change in robotics, because over the past decades, Industrial robots depended on extremely predictable environments, with everything needing to be fixed, controlled, and repetitive. Small physical changes were already enough to cause many failures. Now we are slowly starting to build machines capable of physically improvising in our real world. Boston Dynamics itself states that this AI is one of the biggest evolutions of the Atlas robot because it helps reduce the famous gap between simulation and reality. The problem is that historically, robots work perfectly in virtual environments, but fail miserably when they encounter the unpredictable chaos of our physical world. And there's something really interesting about all of this, okay? Those athletic movements that used to seem like just marketing, like backflips and extreme balance, for example, now start to make perfect sense industrially. According to the company, these skills help develop slip recovery, dynamic stability, thermal resistance, and body adaptation for real work environments. In other words, my friends, maybe those impressive videos were never just a spectacle made for us. Maybe they were actually training in disguise to prepare these machines, which will be able to replace human physical labor on an industrial scale. But those robots won't just be used on Earth, okay? Space is already part of the plan. However, before sending those robots there, in large numbers, of course, we'll have to improve our ships that will send those robots. Let's check all of that out, okay? This next segment is interesting. Some will like it, and others won't. There's something almost paradoxical happening with SpaceX. The bigger the rockets get, the more the tests seem like spectacular failures. And at the same time, the closer the company may get to something that could actually permanently change space exploration. The latest example of this happened during the T-34 flight of Starship V3, the most powerful rocket ever launched by humanity. With 124 meters in height and powered by 33 Super Heavy engines at its base and another 6 Raptor engines on the upper stage, the Starship took off from Starbase in Texas in one of the most important tests in the company's recent history. And right at the beginning, the first problem appeared. One of the auxiliary engines simply didn't fire during liftoff. Even so, the system managed to ascend normally and perform stage separation at high altitude over the Gulf. Up to that point, everything was relatively under control, right? But the most delicate part came afterward. The gigantic Super Heavy booster tried to return for a controlled landing in the ocean as planned. But during the reignition maneuver, several engines failed again. The rocket lost stability, started spinning, and ended up breaking apart violently when it hit the water. And even after losing the largest reusable booster in history, the mission was still partially successful. Why? Because the upper stage of Starship continued its journey alone. During the flight, the spacecraft released 20 simulated Starlink satellites, as well as 2 satellites equipped with cameras to capture images of the thermal blackout during atmospheric re-entry. And even after also losing 2 Raptor engines during ascent, the system managed to reach almost 200 kilometers in altitude. This reveals something very important about SpaceX's philosophy, because unlike the traditional aerospace industry, the company seems to treat explosions and failures not as exceptions, but rather as a rule, as a normal part of the machine's evolutionary process. Each launch can destroy billion-dollar hardware, but it produces absurd amounts of real data that are impossible to obtain through simulations alone. And the ultimate goal is gigantic. Starship wasn't created just to launch satellites, all right? NASA, for example, is betting heavily on it as the future lunar module that will be crewed in the Artemis program, which will be responsible for taking humans back to the moon later this decade. At the same time, Elon Musk still sees his spacecraft as the centerpiece for the plan to colonize Mars. Yes, Elon Musk still thinks a lot about that. And maybe that's exactly the point that makes these tests so fascinating, because right now, in real time, we're seeing experimental technology trying to push past physical limits that, for decades, seemed impossible for human beings to overcome. Extreme reuse, controlled landings, rockets reversing and being fully reusable, and interplanetary missions are starting off a bit slowly, but they're already becoming reality. Of course, the failures are still huge, aren't they? But there's something that's historically inevitable in all of this, because every time the Starship explodes, it also brings humanity a little closer to the idea of turning space into continuous operational infrastructure, and not just isolated missions. And deep down, maybe that's the logic behind SpaceX. To keep failing fast until traveling between planets no longer feels like science fiction. And when all of this is ready, it's these robots here that you're about to see that will be sent into space. Let's take a look. What should the body of a robot created exclusively to live in space be like? Well, science fiction imagined mechanical astronauts with legs, helmets, and a human appearance who would be walking around orbital stations, as if space were just a futuristic version of Earth. But aerospace engineering started to realize something quite curious. In zero gravity, legs might be completely useless. And it was exactly this logic that led the Canadian company Orbit Robotics to create Helios, a humanoid space robot that almost completely abandons traditional human anatomy. Instead of legs, the robot has 4 arms, which are articulated and designed to move by grabbing onto the metal structures inside space stations and orbital satellites. And the result looks almost like an alien organism shown in fiction. But there's a very rational reason behind all of this. On Earth, legs exist because we constantly need to overcome gravity. Walking is basically a continuous struggle against our own body weight. In space, this problem disappears. In microgravity, movement doesn't depend on steps, but on anchor points and motion control. So the engineers at Orbit Robotics came to a simple and logical conclusion, right? If the robot doesn't need to walk, it makes more sense to turn its legs into tools. With 4 arms, Helios can attach part of his body to the station's structure while using his other limbs to perform tasks simultaneously. Something that is extremely important in orbital environments, where any wrong move can push the operator far away from where they wanted to be. The robot's internal engineering is entirely different from traditional industrial robotics. Instead of using rigid joints and heavy motors spread throughout the entire body, the main actuators were positioned close to the shoulders to reduce the mass in the moving arms. The force is transmitted through cables, pulleys, and coils that work almost like artificial biological tendons. And this makes the movements much lighter, smoother, and more energy efficient. Helios' elbow, for example, uses a rolling contact joint with extremely low friction, and this allows for extremely delicate manipulations in the vacuum of space. In space missions, small impacts or vibrations can cause huge problems, so mechanical smoothness becomes just as important as strength itself. And all of this exists for a very clear financial reason. Yes, it all seems like science fiction, I know, but it's already happening now. Even the Star Wars speed air bike, remember that one? It's also already being created. Shall we check it out now? A startup called Volanaut decided to turn what we saw in Star Wars into a functional prototype called the Air Bike. The company released real images of the vehicle flying between the trees, while a pilot dressed as an Imperial soldier was flying this machine in a surprisingly stable way. But behind the cinematic aesthetics, there is an extremely serious engineering project focused on the future of personal air mobility. Volanaut's proposal is to develop VTOL vehicles, an electric aircraft capable of vertical takeoff and landing, which would be able to operate as a mix between a motorcycle and a manned drone. But there's a very important detail here, okay? Piloting something like this in the real world is absurdly more difficult than it looks in the movies, all right? Classic Star Wars bikes looked light and agile, but a real flying vehicle constantly has to deal with aerodynamic stability, gusts of wind, weight distribution, and continuous micro-corrections for balance. So the engineers at Volanaut went with a different approach. Instead of relying solely on human skill, the air bike uses multiple electric rotors combined with automatic stabilization systems based on what? On AI-powered flight control software. In practice, this embedded intelligence corrects tilt, altitude, and wind compensation in real time, allowing the pilot to focus more on navigation than on their own survival. It's almost as if part of the flight is shared between the human and the algorithm. During the test, the human pilots operated at relatively low and controlled altitudes, usually around 15 meters high, especially in dense forested areas. If you fall, that's it, I know that. 15 meters is really high, And the goal is still more related to validating stability and safety than to truly extreme speed. Technologies that started as cinematic fantasies are now beginning to become real prototypes, powered by batteries, artificial intelligence, and automated flight control. And this next technology we're about to see might be another one of those. Or maybe not, right? You'll only know by seeing it. Let's go. Chinese cities are starting to implement robotic barber booths powered by artificial intelligence, which use 3D scanning to map the human customer's head and cut the hair, not the head, with millimeter-level precision. For about 60 yen per session, the idea points to a future where everyday services become automated cheaper, and available on demand. This is the sentence that's in a social media post and has gone quite viral in recent days. The machine moves the blades precisely. What we're seeing is unbelievable. It talks to the client, follows the shape of the face, and outlines almost perfectly just like a human professional does. A skilled professional, of course. Millions of people watched that, believing that the future had really arrived in beauty salons. But there's a problem here. The video is fake, my friend, and maybe that's even more important than the robot itself. In recent months, the internet has started to enter a new phase that is extremely dangerous, where AI-generated videos are becoming so realistic that you can't even tell if they're real or not. We're no longer just talking about weird images with deformed fingers or artificial movements. Now, my friends, AIs can create perfect lighting, natural expressions, convincing physics, and even cinematic camera movements with just a few minutes spent on a prompt. The video of the robotic barber is an excellent example of this. I doubt you didn't believe it was real, especially since it came from a renowned channel like Realidad AI isn't just creating pretty images. It's starting to create artificial versions of our world, which are capable of fooling millions of people while everything is happening. And the scariest part is that this isn't something that's going to happen. It's already started happening. And if you want to stay up to date with all of this, with what's real and what technology is really bringing to us, make sure you're subscribed here to Realidad, okay? If you really like our channel, leave a like. There are 2 new videos on your screen. Just click and I'll see you soon, okay? Click there and I'll see you there. Bye. Bye. Thanks again and go ahead. Click there.